had reached a consensus. The object was confirmed, catalogued, and named 3I, the third interstellar object ever discovered, following Oumuamua and Borisov. And because the Atlas survey had first sounded the alarm, it inherited the name 3I Atlas. Unlike its predecessors, however, Atlas was not content to skim the outskirts of the system or slip by unnoticed. Its course was aimed directly through the inner solar system, and its behavior was already beginning to show anomalies. From the moment of discovery, it was clear. Atlas would not just join the short list of interstellar objects. It would redefine it. As 3I Atlas drew closer, astronomers expected it to behave like a comet. At 6.5 astronomical units from the Sun, still farther than Jupiter's orbit, an ordinary comet remains frozen, silent, and dim. The solar heat at that distance is far too weak to vaporize water ice, the primary driver of comet activity. In theory, Atlas should have been a cold and nearly invisible speck, waiting until it moved much closer before showing signs of life. But Atlas defied those expectations. Instead of staying faint, its brightness began to surge, not in a steady, predictable increase, but in sudden, pulsing bursts. For hours, even days at a time, its light curve would rise, then fall again, as though the object itself were breathing. Astronomers watching its behavior described it as a cosmic heartbeat, flaring, fading, then flaring once more. This is not how comets behave. Typical outgassing produces a smooth and gradual brightening as sunlight drives sublimation of ices. Atlas's stuttering glow suggested something very different. An internal process, not simple solar heating. Perhaps pockets of volatile material deep within its nucleus were erupting in bursts, triggered from within. Or perhaps it was something stranger, a mechanism unseen in any natural comet before. Each pulse carried energy, dust, and gas into space, leaving behind faint trails that puzzled observers. The rhythm was unlike anything in cometary science, leaving researchers struggling to explain how a body from deep interstellar space could generate such controlled, episodic outbursts. Was Atlas merely a comet with exotic chemistry, or did the pulses reveal something more deliberate, something almost mechanical? No answer came quickly, but one fact was undeniable. This was no ordinary piece of cosmic ice. Atlas was alive with activity long before it should have been, and its heartbeat echoed across telescopes on Earth. A mystery unfolding in real time. As 3I Atlas continued its journey inward, astronomers turned their telescopes to its trailing dust tail, expecting familiar patterns. Comet tails usually stream away from the Sun, driven by solar wind and radiation pressure, forming graceful arcs that follow predictable physics. But Atlas refused to behave. High-resolution images revealed segments of the tail curving sunward, pushing against the expected flow. Dense clumps of dust lingered, moving sluggishly, defying the very models that explain cometary behavior. Spectral analysis added another layer of mystery. The tail was dominated by heavier grains, particles that should have been trapped in the nucleus or dispersed quickly into space. The material streaming off Atlas did not conform to the familiar light, fast-moving dust of ordinary comets. Every measurement challenged existing physics. Meanwhile, brightness observations suggested the comet was ejecting far more material than its estimated nucleus of less than 6 kilometers could account for. Scientists debated furiously. Could the core be far larger, perhaps 10 kilometers across, making Atlas one of the largest interstellar objects ever recorded? Or was something else happening? Internal fragmentation, hidden caverns of volatile material, or even previously unknown mechanisms driving the outflow? The debate is more than academic. Understanding the mass and structure of Atlas is critical to predicting its future behavior as it sweeps through the inner solar system. A larger, more massive body could survive perihelion, passing intact through the Sun's heat. Fragmentation, on the other hand, could scatter debris along its orbit, offering fleeting glimpses into its interior, but creating hazards for observation. Atlas's tail, its puzzling density, and its immense ejection of material make it clear. This is not a routine visitor. Every anomaly deepens the mystery and forces astronomers to question assumptions that have guided comet science for decades. Atlas challenges not only our models, but our understanding of what is possible in the solar system. As 3I Atlas hurtled toward the inner solar system, the world's most powerful eyes in space and on Earth sprang into action. But quietly, almost invisibly. The James Webb Space Telescope, normally booked months in advance with crowded observation schedules, carved out precious hours to focus on the interstellar visitor. Its NIR spec and MIRI instruments were repurposed to search for the building blocks of planets. Pristine molecules, complex organics, silicates, and even carbon monoxide preserved from the object's journey through the stars. Meanwhile, Hubble pivoted to high-cadence imaging, snapping rapid sequences to track every flicker of brightness and every subtle shift in the tail. At the same time, solar observatories such as SOHO and Stereo prepared their coronagraphs, designed to block the sun's glare and reveal the faintest plasma streams, hoping to catch Atlas as it skimmed perilously close to perihelion. Yet this extraordinary mobilization of instruments came with a twist. Most observations were conducted under strict data embargoes, often marked with phrases like operational security. Conference sessions that might have shared early results closed their doors. Only a few carefully vetted scientists were allowed access. Leaks trickled out into the amateur networks, hinting at discoveries but revealing little substance. It was as if the cosmos had handed humanity a message, and the keepers of the telescopes were holding it close to the chest. For months, teams coordinated behind the scenes, logging every photon, measuring every spectral line, and tracking every pulse of dust and gas. Each observation was critical, for once Atlas reached perihelion, Earth-based telescopes would be blind, forced to watch from millions of miles away. Every second of observation before that point became precious, and the secrecy surrounding the campaign added an air of tension. The world would soon see Atlas, but only on terms dictated by those in the know. In the shadows of embargoes and quiet coordination, the stage was set. 3I Atlas was approaching its closest point to the sun, and humanity's finest instruments were ready. Their eyes trained, yet their mouths silent. While the world's largest telescopes operated under secrecy and data embargoes, a different network quietly sprang into action. Across South Africa, Chile, and Australia, amateur astronomers mobilized, forming an international web of vigilant observers. Armed with backyard telescopes, CCD cameras, and spectrometers, these dedicated individuals became humanity's front line in monitoring 3I Atlas. They tracked every heartbeat of the comet's brightness, every pulse and flicker that hinted at internal activity. They noted subtle kinks in its dust tail, segments curving against the solar wind, and dense clumps moving in ways that defied conventional physics. Using coordinated timing, they compared observations across continents, creating a near-continuous log of Atlas's activity as it raced through the inner solar system. Often, they spotted changes hours before professional observatories reported them, becoming the unofficial custodians of the object's unfolding story. Yet even this grassroots network faced limits. Rumors circulated that some anomalies were being censored or quietly downplayed, information either scrubbed from shared channels or met with skeptical caution. The amateurs were left piecing together a narrative from fragments, their excitement tinged with frustration. Still, without their tireless efforts, the story of Atlas would have been far less complete. In the shadow of institutional silence, these citizen scientists kept the data flowing, filling in gaps that might otherwise have remained blank. Their vigilance transformed simple backyard observations into a vital complement to the high-powered instruments orbiting the Sun, ensuring that humanity did not entirely lose sight of this extraordinary interstellar visitor. Atlas was no longer just an object in the sky. It was a puzzle spanning the globe, with professionals and amateurs alike racing to capture every pulse, every twist, and every whisper from a comet that seemed to defy everything we thought we knew. On October 31, 2025, 3I Atlas reached perihelion, the closest point to the Sun on its unprecedented journey through our solar system. For Earth-based observers, the timing could not have been more frustrating. The Sun's glare forced JWST, Hubble, and other powerful telescopes offline, entering a forced blackout due to solar conjunction. For nearly 2 weeks, humanity's most sensitive eyes were blind to Atlas at the very moment it was most active, leaving Mars orbiters as the only spacecraft capable of direct observation. Controllers scrambled, rotating spectrometers, retuning cameras, and squeezing every last observation window before communications would be disrupted by the Sun. Scientists faced 3 potential fates for Atlas. First, fragmentation. The nucleus could break apart, scattering debris along its orbit and revealing hidden internal structures. Second, an explosive flare, where volatile-rich regions of the comet might erupt violently, releasing gas and dust in a single dramatic event. Finally, survival intact, the most unsettling possibility of all. A durable, large interstellar object, traversing the inner solar system on a flat, nearly mission-like trajectory, would challenge everything we understand about cometary physics and the nature of interstellar visitors. Even now, questions linger. What caused its rhythmic brightness pulses? Why did its dust tail bend against the solar wind? How could its estimated mass and outflow rates exceed predictions for a nucleus of its size? And above all, is Atlas a natural comet or something far more extraordinary? As the blackout period ends and Earth regains partial observation capability, astronomers and amateurs alike continue to study the data streaming from Mars orbiters and the occasional solar observatory glimpse. Yet, for now, 3I Atlas remains a cosmic enigma, a visitor from the stars whose behavior, path, and hidden secrets continue to provoke awe, curiosity, and a profound sense of mystery. Its journey through the solar system may be brief, but the questions it raises will resonate for years to come, challenging the very boundaries of what we believe is possible. If you found this journey through hidden science, cosmic secrets, and potential alien infrastructure as mind-blowing as we did, make sure to subscribe and hit the notification bell. Don't miss future explorations into the universe's deepest mysteries, because some secrets are just waiting to be uncovered.